In a moment that sent ripples across the scientific community, NASA's James Webb Space Telescope has made a discovery that may forever reshape our understanding of the universe. Only weeks after capturing the light of what appears to be the oldest known galaxy, Webb's powerful instruments have now detected something even more astonishing: a supermassive black hole traveling at an extraordinary speed of nearly 4 million miles per hour, ripping through the cosmos and leaving a trail of newborn stars in its wake. Let that sink in for a moment. A black hole, an object so dense that not even light can escape its gravity, has somehow been launched from its home galaxy, and it's not just drifting through space. It's moving with such immense velocity that it could travel from Earth to the Moon in under 4 minutes. What's even more bewildering is that this black hole isn't just a cosmic wrecking ball. As it carves a path through intergalactic space, it's compressing gas in its wake and triggering the formation of stars, forming a glowing trail more than 200,000 light-years long. That's nearly twice the diameter of our entire Milky Way galaxy. The discovery was led by Yale University astronomer Peter Van Dokkum, whose team stumbled upon the anomaly while reviewing data from the Hubble Space Telescope. They noticed an unusually straight, bright streak of light stretching across the image. Upon closer analysis, they realized that this streak wasn't a defect or a background galaxy. It was a star-forming tail, likely created by a runaway black hole plowing through interstellar gas. But how does something as gravitationally dominant as a black hole get ejected from a galaxy in the first place? The leading theory suggests a triple black hole interaction. Imagine 3 galaxies merging, a chaotic and violent process. In the heart of each galaxy lies a supermassive black hole. As these giants spiral inward and interact, their gravitational forces can create a slingshot effect. One black hole is expelled at incredible speed, leaving the remaining 2 behind. In this case, the ejected black hole continues its journey alone, tearing through gas and igniting star formation in its wake. While black holes are generally associated with destruction, devouring stars, warping spacetime, and collapsing matter into singularities, this observation flips that notion on its head. Instead of consuming, this black hole is creating. Its gravitational influence compresses interstellar gas, leading to the birth of new stars. It's like a cosmic paintbrush, streaking across the void and leaving behind a glowing trail of stellar light. And this is only one of many breakthroughs achieved by the James Webb Space Telescope. In another stunning observation, JWST has provided the clearest and most detailed images of ARP 220. One of the closest and most luminous examples of a galactic merger ever recorded. Located approximately 250 million light-years away in the constellation Serpens, ARP 220 is what astronomers refer to as an ultraluminous infrared galaxy, radiating more than 1 trillion times the luminosity of our Sun. This brilliant glow is the result of 2 spiral galaxies colliding and merging. About 700 million years ago, these galaxies began a slow gravitational dance, their mutual attraction warping their shapes and pulling stars and gas into chaotic orbits. As their cores spiraled closer, they triggered a burst of intense star formation, what scientists call a starburst event. In just a region 5,000 light-years across, over 200 massive star clusters formed, many of which are still hidden behind dense clouds of dust. Radio telescopes have even detected over 100 supernova remnants within this compact area, a testament to how many stars have already formed, lived, and exploded in this tumultuous environment. The Hubble Space Telescope previously revealed that the 2 galactic nuclei in ARP 220 are now just 1,200 light-years apart, embedded within a turbulent sea of gas and dust. But with the power of infrared imaging, JWST has gone even deeper. It uncovered filaments of reddish-orange light, possibly made up of organic molecules like polycyclic aromatic hydrocarbons, being stretched and twisted by gravitational forces. These materials are being drawn out by the intense tidal forces of the merger, forming intergalactic bridges of glowing gas and dust. It's a mesmerizing sight, a cosmic collision frozen in time, captured in exquisite detail. Yet perhaps the most revolutionary revelations from the James Webb Telescope come not from nearby galactic mergers, but from the very edge of the observable universe. One of JWST's primary goals is to observe the first galaxies that ever formed, structures born only a few 100 million years after the Big Bang. And it has exceeded expectations. The telescope has discovered ancient galaxies so distant that their light has been traveling for 13.5 billion years to reach us. These galaxies existed when the universe was just 2% of its current age. What's truly baffling, however, is their size. Many of these early galaxies appear to be massive and mature, with well-formed structures, dense star populations, and even central bulges, features thought to require billions of years to develop. This poses a direct challenge to the standard model of cosmology. According to current theories, galaxies should have formed gradually, building up mass over time through the slow accumulation of gas and the merging of smaller systems. But the galaxies seen by JWST seem to have skipped ahead, achieving levels of organization and mass that defy current understanding. Astrophysicist Michio Kaku has commented on this phenomenon, stating that the discoveries coming from JWST may lead to a rewrite of the Big Bang theory. He points out that if galaxies of such size and complexity already existed just a few 100 million years after the Big Bang, then our models of early cosmic evolution might be missing critical pieces. Could it be that the universe expanded and cooled faster than we thought? Or are there unknown physical processes at play in the early cosmos? One possibility is that dark matter and dark energy played a more significant role in early galaxy formation than we currently understand. Alternatively, perhaps our estimates of cosmic time and redshift need revision. Some have even suggested that the laws of physics themselves might have been slightly different in the early universe, allowing for rapid star and galaxy formation. These are not minor tweaks. These are paradigm-shifting questions that strike at the heart of how we understand the universe's origin. Another recent breakthrough from JWST involves the detection of a protocluster of galaxies formed just 650 million years after the Big Bang. This discovery is critical because it shows that large-scale cosmic structures were already taking shape during the universe's infancy. These protoclusters are the building blocks of today's massive galactic clusters, regions of space containing hundreds or even thousands of galaxies bound together by gravity. Seeing such formations so early again suggests that galactic evolution began faster and more efficiently than previously believed. NASA scientists described it as witnessing the birth of a cosmic river, with small streams of matter merging into a greater current. It's a direct look into the mechanics of how complexity arose from primordial chaos. With each new image and dataset, the James Webb Space Telescope challenges us to look deeper, not just into space, but into our own assumptions. It's no longer just a question of what's out there, but how did it get there so quickly? The runaway black hole forming stars, the galactic mergers glowing with the light of countless suns, and the ancient, massive galaxies that shouldn't exist. All of these are clues in a grander cosmic puzzle. As we move forward, the data from JWST may lead to new physics, revised cosmological models, and perhaps even a deeper understanding of time, matter, and the nature of reality itself. The universe is far more dynamic, complex, and surprising than we ever imagined. At Discovery at 2.0, we'll continue to explore these awe-inspiring developments, decoding the mysteries of space, time, and everything in between. Because with every observation the James Webb Space Telescope sends back, we are not just observing the past. We are witnessing the dawn of a new cosmic era.